min? Is there max, first of all?
No.
So let's take a look. Follow the marker.
Oh, okay.
Is there a max anywhere? We call it local max or relative max. Is there a
Wouldn't
local?
it be the arrow going up?
So right this at this point, do we see a local max?
When it's constant.
So
Or when it's zero.
what exactly? In this case, the slope is 0, yes. And as you see, the derivative is positive, then it's 0, then it's negative. This is specific for a max. First, it has to be positive, the derivative, then it has to be 0, and then it has to be negative. Do we see, so local is also called relative. We use those two interchangeably. If we say local max, we mean relative max. If we say relative, we mean local, same thing. Do we see a local minimum here? Do we?
Yeah.
Yes, right here. What happens to the derivative? First, it's negative, then it's 0, and then it's positive. So this is typical for local min. It has to be this particular sequence of signs. Positive, 0, negative, or negative, 0, positive. So then, what is a max? A max requires positive, 0, negative for the derivative. Positive, 0, negative. A minimum requires negative, 0, positive. There is a second option though. Positive undefined negative. And of course here, negative undefined positive. So these are the possibilities for max, and these are the possibilities for min. What happens if it's positive, 0, positive? Is that a max or a min? What do you think? Positive, 0, positive. Is there a max or a min? Yes or no?
No.
No max or min. What about negative, 0, negative? Is there a max or min? Negative, 0, negative. Is there a max or a min? Anyone?
No.
No. What about positive undefined positive? Is there a max or a min? Or negative undefined negative? Is there a max or a min? So we say here, if there is no sign change this way or this way, there is no max min. So none of these have a sign change. If there is no sign change, there is never max or min. Okay, so let's illustrate what we just talked about. We can say it's a mouthful. Yes, it is. But it will be very easy when we look at examples. I'm just trying to find the page number, and the page number is 276. Okay, I hope I'm not logged out. Okay, here it is. Where's my book? Here it is. Again, it's 276. 276, enter. Okay. So first, we're going to take it slowly. We're going to find we are going to find critical numbers. We'll come back to graphs and everything. I'll explain the graphs. I just want to look at a function and find its critical numbers, and then discuss if they turn into max or min. Okay, so let's start with a simple polynomial function. So let's try 47. That's our first example. And we have g of x equals x to the third minus 6x squared plus 10. No, we're not gonna sketch the graph in 3.1. No. Not possible yet. So we have a function. Number one, let's find critical numbers. Remember, critical numbers come from potentially two sources. G prime of x equals 0. Solve this equation and find x. And or g prime of x is undefined at a point where the function exists. So both of them refer to g prime. Can anyone give us g prime of x for this function? Anyone? We should not have any difficulties with this. We should just write the derivative. What is it?
3x2
Yes?
minus 12x.
Excellent. Perfect. Let's discuss this possibility first. Can this function be ever undefined? Can this function be ever undefined? What is the domain of such a function? Can anyone give us the domain of this function? What do you think? What do you think?
Negative infinity, infinity.
Great. Excellent. So this is not possible. Remember the functions that are that could potentially undefined: square root, natural log. These are the functions that we discussed. Or let's say 1 over x plus 3. These are functions with restrictions. Natural log requires x minus 3 to be strictly greater than 0. Here, x plus 1 greater than or equal to 0. And here, x plus 3 cannot be 0. These are the functions with problems. Polynomial, never problems, ever. These are the problems. This is friendly. So there is nothing coming from that source. Nothing. No critical numbers will come from this because this is always defined. Awesome. So now I'm here. I have to set g prime equal to 0. G prime of x equals 0. So I have 3x squared minus 12x equals 0. How do I solve this equation? Remember, you do have the calculator. It's quadratic. You have to come up with two solutions, and you can use the calculator if that's what you want. But this is too easy to use the calculator. What would you do? And please say, simplify first by 3. So I'm going to divide both sides by 3 and get x squared minus 4x equals 0. Then what would you do? If you don't want to use, or we don't have to use the calculator on something like this. What would you do to get the two solutions? Quickly, please. Anyone? Anyone, please. Can anyone give us the solutions for this? What would you do? How do we determine the solutions here? Please, anyone? Donnie, say it again.
Factoring.
Yes, I factor out x. And the solutions are?
0 and 4.
Excellent. These are critical numbers. So that was number 1. Number 2. Are these max min? The answer is no clue. I will know. So here's what I do. This is a very important table, please. G prime of x, g of x. You already told me the domain because it's a polynomial function. It must have all real numbers. We already know that there are 2 critical numbers. 0 is first and 4 is the next one. G prime at 0 and G prime at 4. What do I put right under 0 and 4 for G prime? That's how I found them. By setting G prime equal to 0, and that's how I found 0 and 4. I'm going to copy G prime here, so I don't have to go back to the previous page. And it was 3x, x minus 4. Good. Now, I will plug in the function. I will find this value in the function, and this value, plugging in 4. And the function was, I still have to go back. Let me copy it here. G of x equals x to the 3rd minus 6x squared plus 10. I'm going to plug this function in to find 0. Well, 0, 0 is 10. That's clear. And for 4, G of 4, it's 64 minus 6 times 16 plus 10. How much is that? Quickly, 64 minus 6 times 16 and plus 10. I got negative 22. Okay, perfect. So now, I need to determine the sign of the derivative here, the sign of the derivative here, and the sign of the derivative here. So to the left of 0, let's say we plug in negative 1. Negative 5 times negative 3. What is the sign of the answer? Negative 5 times negative 3. And I'll put the sign here. Negative 5 times negative 3 will give us what sign? How much is negative 5 times negative 5 times negative 3? Anyone? So I picked a number here. I don't want to put it in the table. But this is the number that I...
Negative 5 times negative 3?
Yes, negative 5 times negative 3. What will be the sign?
15.
Very good. So the sign is positive. I only need the sign. Now I'm going to plug in 1. This is 3 and this is negative 3. I only need the sign of 3 times negative 3 and I'll put it here.
Negative.
Excellent. Thank you very much. Finally, I'm going to pick 10. 30 times 6. I just need the sign.
Positive.
Thank you very much. So now, what does the function do when the derivative is positive? What did we say? When the derivative is positive, the function, what does it do? When the derivative is positive, the function must be let's take a look. When the derivative is positive, the function is
Increasing.
thank you very much. When the derivative is negative, the function is
Decreasing.
thank you very much. When the derivative is positive, the function is
Increasing.
thank you. So then, what type of point is 0, 10?
A max.
Very good. Local max, awesome. Now, what type of point is 4, negative 22?
Okay.
That's it. So that's why, please understand that this table is extremely valuable. It will also, of course, this is our first example, and this is a simple situation, right? It will always tell us whether these values make sense. So if the derivative is negative, and if this number, by mistake, I would have wrote, let's say, I would have written 50 instead of negative 22. I would have said, wait a minute, this cannot be 50. The function is decreasing from 10. So we also catch our mistakes. So this row has to work well with these numbers, because if there is no sync between those two, then I'll say, oops, something is wrong. So we found two critical numbers or values, x equals 0, x equals 4. It turned out that 0, 10 is a local max, and 4, negative 22 is a local min. So again, what did we learn? We learned the intervals of increasing and decreasing. What are they? So the function is increasing between negative infinity 0, for x between negative infinity and 0, union 4 to infinity. And the function is decreasing between 0 and 4. So based on the derivative and the sign, we found critical numbers. We solved the equation and we found two critical numbers, x equals 0 and x equals 4. This was redundant because our example was a polynomial function. The function had critical numbers, and they happened to turn into max-min. Why? Because the derivative changed sign left and right of this point in this specific way for a maximum, and in this order for a minimum. So we learned a lot from the derivative. And yes, later on we were going to graph. We're not ready to graph yet. So I'm going to sign something for you, but I don't want you to graph. We're not graphing at this point. We don't have enough information for graphing. But we learned a lot about this function. So it's coming from below, it reaches a maximum, it comes down to a minimum, and goes up. We potentially are able to graph it, but we're not ready for that. So it's something similar to this. It comes and decreases, goes to a maximum, comes down to a minimum, and goes up to infinity. Something similar to that. Any questions? So chapter 3 is a big deal. Looking at the time, yes. Chapter 3 is a big deal. This is just a preliminary.